Good day, everyone. It is nice over here for you and I because learning never ends and education is the key to an impactful life. My name is Anthony Nathaniel. Good day, everyone. My name is Anthony Nathaniel, and in this 8th episode of our Christ Secondary School Physics, we are going to be dealing with the particulate nature of matter. And I implore you to watch to the end of this video so you can gain as much as possible. Now, the particulate theory of matter is quite tied to the kinetic molecular theory of matter, which states that matter is composed of molecules which are in incessant and constant motion. Now, this matter, from early days, scientists knew that matter was composed of tiny particles, but they did not know how tiny they are. But then, in the ancient Greek, they called them atoms. But the atomic theory was postulated in the modern era. So, and then we also have the models of the atom, which helped us to have a more cursory view into the nature of the atom. But majorly, there were experiments that helped us to verify the atomic nature of matter, like the Brownian movement and Brownian motion. And we also have the law of definite proportions. We have diffusion. For example, in this diagram, you can see a jar of bromine. So now this is water, and when you put drops of bromine, at the end of the day, it will diffuse to fill the whole container. So the color will be uniform throughout the container. So that is called diffusion, and it demonstrates the particulate nature of matter. There are also other evidences too. In these mental terms, we can understand atoms by the means of understanding their atomic structure. And then the atomic structure, the simplest way you can understand them is by drawing only our attention to the nucleus and the electrons. Now, as you can see, this looks like a range of concentric circles. Now, the center circle contains a group of other circles, and those circles, they represent the nucleons. Now, these nucleons, they are consisting of the protons and neutrons. And then outside the other concentric circles outside this circle, they are called the electron clouds or the electron shells. Now that's the simplest way you can understand the atom. But we won't go into other advanced atomic structure and theory like Bohr's theory and wave mechanics model. No, this is just supposed to be an introduction into this. Now the nucleus is the heavy portion of the atom and is located at the center. And it also contains the protons and neutrons. The protons carry a positive charge and the neutrons carry no charge, whereas the electrons carry a negative charge. But the protons and neutrons, they have the same mass, whereas the electron is virtually massless compared to the protons and neutrons, but it has a very negligible mass, which is 1 over 1840 times the mass of either of a proton or a neutron. So this is basically how it looks. Now let's talk about the molecules, which are basically the substances that they can exist on their own. So molecule is the smallest particle of a substance which can have a separate existence and still retain the properties of that substance. So this is a unique property of molecules. They are like representatives of matter. So if you can see a molecule of matter, you will be able to know how the matter is in general, because matter is just a combination of different similar and identical molecules. So molecule is like a person, an individual of a nation of matter. Next, let's talk about the famous experiment, which is known as the oil film experiment. Now I'll just give a summary of what it is. It was used to estimate the size of a molecule, and it was done in 1890 by Lord Rayleigh, who first estimated the approximate size of a molecule. Now, this is actually of the order of 10 raised by minus 9 to 10 raised by minus 10 meter. But then this is how the experiment goes. You need to pour a clean water into a shallow dish and sprinkle some lycopodium powder lightly on the water. Then next, you obtain a graduated pipette with a fine bore, and with it take up a small volume of an oil, for example olive oil, and then you note the reading on the pipette scale. So you measure the volume of that small volume. Then you drop a very small quantity of the oil onto the water in the dish, and note again the reading of the prepared scale. So you subtract this reading from the first reading to obtain the volume of the oil used, and then finally you allow the oil to spread, pushing the lycopodium powder outward and forming a clear film of oil. So what this means is that basically you are going to pour some water, pour some lycopodium powder on the water, and then pour an oil drop on that lycopodium powder, and then after some time that oil drop will push the powder to the side and it will spread around, forming an approximately one film, one very tiny layer of oil on the surface of the water. Then you can measure the diameter of the oil patch to the nearest centimeter using a half millimeter scale. Then you calculate the thickness of the oil film as follows. So let the diameter of the oil film equals D, let the volume of the oil film equals V. So then area of the oil film will be equal to pi d square over 4. That's area of is a circular shape. Then the thickness of the film will what? So you can make use of volume over area. Then when you calculate the formula, you will get the value. And that thickness, since it's one molecule thick, that means that thickness of the oil layer will be the thickness of a molecule of oil. And for accurate experiments, you have a value of about 2 times 10 to the power minus 7 centimeter. So that is an approximation, and it is actually very close to the actual value. Another effective way of understanding the particulate nature of matter is by the use of smoke cell. Now the smoke cell helps us to observe the movement of smoke particles using a smoke cell and a microscope. The smoke cell consists of a small glass cell with a cover. Now the cell contains a little smoke from a smoldering piece of cord or string, and the cell is strongly illuminated from the side by light, which is focused into the interior of the smoke cell using a focusing lens. Now that focusing lens assists the magnification and the clear view with the microscope. So that's the function. Now the illuminated smoke particles are observed as bright spots of light undergoing a zigzag movement like that of a drunken man staggering about. Now if you plot the points of those points, you see that they will actually be going in random motion without any reasonable direction. So that is called Brownian motion. It's called random or irregular motion and haphazard motion. So this is the setup. That's the smoke cell, that's the glass rod, which is the lens, and then you have the light. So the glass rod also serves to spread the light and makes it diffuse through the smoke chamber. Now, and that microscope above helps it also magnify and see the direct motion of the individual particles. So you can see that particulate nature of matter has been very much investigated in the past. So now, folks, from all these conclusions we've been drawing, let's talk about Brownian motion in detail. So Brownian motion was first observed by Robert Brown, a botanist, in 1827, and it refers to the rapid, constant, and irregular motion of tiny particles. So these particles, they move in not any specified motion, is in a non-specified way, in a haphazard way, and they move in a way that is unpredictable. That is called random motion, and is also generally known as Brownian motion. That has been known through a long time, and it was even applied by Albert Einstein in proving some of his theorems. Now this is a demonstration of liquids and gases, and it helps us to understand Brownian motion more, because this is like a model from the particulate nature of matter. Then you can say that the particles of a liquid are more packed together than that of a gas. So if the gas are randomly spaced, there are a lot of space between the gas molecules, and this is the reason for their lightness and their low densities. And also gases are highly compressible because of the space that is already between the molecules, so you can now reduce those space. But liquids are not very compressible, and then solids, they are the least compressible. So this state of matter can also help us understand the particulate nature of matter, and this is how it is basically understood for a long time in science, and it's a very reliable way of understanding the atomic and subatomic particles of matter. So thank you for watching, and I'll see you in the next episode, which will be talking about elastic properties of solids.